Okay, so we are going to look at Chem Live, question 13.14. It is an ethanoic acid titration. So as always, the first thing we do is we work out attic and basement. We always know what goes in the basement will not be a whole number, so that's what we're scanning down through our question to find. So we have average titration figure for what went into our attic. Again, it's never going to be a whole number, so that one is going to be 20. Not having a good morning, am I? 26.55 versus 25 centimeters cubed of 0.09 big M, and from the equation the ratio for both things is 1. So this is our NaOH and this is our ethanoic acid over here. This has to be our question mark, and just to check, it says calculate the concentration of ethanoic acid. So that is our question mark. We also need to see, is there any other information in here? So in terms of our other info, it is this first sentence: a 25 centimeter cubed was diluted to 250. So we're going to use that to work out a dilution factor, and we do that by 250 divided by 25 is equal to 810. Okay, so in this we always start with our W, our first principles, where we're taking our way in, which in this case is going to be here. So the moles in 1,000 centimeters cubed, when we go down, we always divide by 1,000. We find out what's in 1 centimeter cubed. We go up and we multiply by that tighter volume. We apply our ratio across the flask part. We go down, we divide it by the other tighter volume to find out what's in how many moles in 1 centimeter cubed. And finally, to finish it off, we multiply by 1,000 to find out what's the big M value, moles in 1,000 centimeters cubed. We will also at some point be using our mass triangle with the molar mass that we'll calculate in the bottom right. And in this one, because we will be working out a percent weight per volume. We will also be working out concentrations for our diluted vinegar and for our original. So we just follow our steps. So the first thing, as you all know, I like to start with 0.09 big M and say what this means. So that's 0.09 moles in 1,000 centimeters cubed. That brings us to here. We're now going to divide that by 1,000 to find out what is in 1 centimeter cubed. And when we do that, 9 by 10 to the minus 5 moles in a centimeter cubed. Now again, whatever your number your calculator gives you, okay, we're on just gone down on our W. Whatever your calculator gives you, that's what you use. We're now going back up. So to go back up, we multiply by the tighter volume, which was by 25. And now we have 2.25 by 10 to the minus 3 moles. And that is in 25 centimeters cubed, which is our first tighter volume. So now we have gone up to here. On our W, we're now going to apply our ratio, which is the flat part of our W. Our ratio is 1:1, so that implies I must have 2.25 by 10 to the minus 3 moles, but now this is going to be in 26.5 centimeters cubed. That is our other tighter volume, so now we've applied our ratio on our W. We're now going to go down and we're going to find out how many moles there are in the 26.55. To do that, we divide our moles by 26.55. And when we do that, we get 8.47 by 10 to the minus 5 moles in a centimeter cubed. That brings us to here on our W, and now we're going to do our last bit, which is going back up, and we are going to multiply it by 1,000 centimeter cubed. And when we do that, we get 0.84745 big M. Now, if I leave that with all of those significant figures, the examiner is going to count it as a slip and they will be taking one away from you because it's not accurate. So we always look to our data table, and if in doubt, 3 significant figures. But technically we have 4 significant figures up here, so we can go to 4 significant figures down here. And to do that, we count 1, 2, 3. This is our 4th significant figure, so we always look at the number that comes after, which is a 5. So it'll round up 8475 big M. And this now is the concentration of my diluted vinegar. From there, we always go into our mass triangle. So it's going to be moles by molar mass, which in this case is going to be, I apologize, I've just recognized that I have, I'm a 0 out. So give me 1 second to recover that. So it'll be 0.08, 0.08. And remember, if the zeros are at the beginning, so the zeros are here, they are not significant. But if there's a 0 in the middle of a group of numbers, that could be. So we are going 0.8475, and we're going to multiply that by molar mass. So again, we always show the examiner all our workings out, because if we just give them a number and that number is wrong, then we will end up again having a slip. But if I have all of these numbers right, and say for some reason I wrote down 59, then you will see it'll be a slip on your paper. Okay, so we show them everything and we try to be as accurate as possible. So we're going to multiply our concentration by 60. And when I do that to 4 significant figures, I'm getting 0.0847, and then the 7 rounds the 4 up to 5 grams in a litre, and this is my diluted vinegar. So we've done everything that we normally do, and now we go back up and we just check our question. So up here it is asking us to calculate the concentration of ethanoic acid, which we've done, but it's now in the original vinegar, and it wants it in big M, in grams per litre, and percent weight per volume. So we go back and we find the relevant parts. So our first part is going to be this 0.0845. That's in our diluted. We already know from up here that our dilution factor is 10. So to find out what's in the original vinegar, it becomes very straightforward. 0.08475 big M by 10 gives us my original concentration. So 8475 big M. This is going to be the answer to part A. The next thing that we have to do is we have to convert this to the original vinegar. So again, all we're doing is we're multiplying this by 10. And when we do that, we get 50.85 grams in a litre. So that is my original vinegar. So this is my part B. So that gets that annotated. I might just double up my colours. Okay, so these are our boxed answers. And again, if you can't annotate, that's fine. You just have method to how you're putting it on paper. And as long as your examiner can follow it, it should be fine. So the last little bit is percent weight per volume. And again, if I had €1 for every time someone got this wrong, I would be so rich. So it means grams per 100 centimeters cubed. So I know I have 58.5 grams in 1,000 centimeters cubed. So I need to find out what's in 1 by dividing it by 1,000 and multiplying it by 100. And that will give me 5.085 grams in 100 centimeters cubed, which is exact same as saying 5.085% weight per volume. This is my last part of C. Now, it is, if you can, some people will see it straight away, I can take this value here, and I can literally, if I divide that value by 10, that will give me my percent weight per volume grams in 100 centimeters cubed. So however you get there, it doesn't matter, as long as you get there.